Welcome back to the Calculus Lecture Series. In this episode, we're going to be looking at the power rule and what that means. So basically, in the last episode, we looked at, the limit definition of a derivative, how we can find the slope of a tangent line given a function by using what's called the difference quotient, f of x plus h minus f of x all over h, the limit as h approaches 0. That's a big pain in the ass, so Sir Isaac Newton made some rules. He made the power rule here, which states that if f of x equals x to the n power, well, f prime of x is then equal to, let's bring that exponent down, multiply it by x, and then let's take x n minus 1. So for example, if I had x squared, we said that in the last video that the derivative of x squared was 2x, right? How could we use the power rule to prove this? Well, we take x and we bring it out front, and then we subtract it by 1. So that's 2x, right? 2 times x. 2 minus 1 is just 1, which is just 2x, right? So you see how that rule works? It takes the whole pain in the ass system of f of x plus h minus f of x over h, and it makes it quite simple. So we can actually use this for even bigger terms, like let's say trinomial, right? X squared plus 3x plus 1, for example. How do we find the derivative, right? And when we take the derivative, we got to put notation. So we're going to say dy dx to say that, d dx to show that we are differentiating with respect to x for that function, right? So let's find the derivative using the power rule, right? All of these require the power rule. I'll tell you that now. There's some where it's not. When you multiply or when you divide or when you have functions to a power, that's when it changes. So let's see here. We said that for x squared, we can bring down the power, subtract the exponent by 1, 2x. All right, now we're adding 3x. We want to find the derivative of 3x. So this is 3x to the first. We bring it out and multiply by that coefficient of 3. So this is 3. And then it's x to 1 minus 1, which is 0. So that x value, anything to the 0th power is 1. So this is really like saying 3 times 1, or just 3. So when you have an x term that's to the first power and you're finding the derivative, in your head think, I can just get rid of the x and it's fine, right? Because the derivative of 3x is just 3. And that's like saying the slope of a tangent line for y equals x plus 3 will always be 3, which is true, right? The slope of this tangent line is constant, or the slope of the function is constant, so the slope of the tangent line will always be constant. Hopefully that makes sense there. But then it's plus 1, which the derivative of any constant term is 0. 0. So this is plus 0, right? Quite simple. And just for simplicity, we'll get rid of it. So that is the derivative. So we'll say d dx is equal to 2x plus 3. Quite simple, right? Let's go on to some harder problems. Number 3 might be a little challenging, but this is going to help you see some common elements that are put into normal calc exams that I've seen, right? So let's go just through 2. It's kind of the same, but here we're going to add coefficients to kind of just get a point across here that when you have a coefficient, we have to multiply. So 3 times, so if we find d dx here, a little change with respect to x, we know that for the power rule, we can do power rule for all these. We bring the 5 forward. It's not just like 3 plus 5, it's 3 times 5. So that's 15x to the 4th, right? Because 5 minus 1 is 4, right? And then plus, and then we're going to bring down the 2. That's going to simplify to 8. 2 minus 1 is 1, 8x. And then 3, again, remember constants are always 0, so that cancels out. So then we're left with d dx is equal to 15x to the 4th plus 8x, right? So that's the derivative of 3x to the 5th plus 4x to the 2nd plus 3, right? Quite simple. Now let's get to something a little more challenging, right? This will probably be ones that you'll see on your exam. You know you're going to go through all these problems, and I highly recommend that watching these videos, you go to things like Khan Academy. They have great practice problems. Paul's Math Notes, right? Don't just take what you learn here and expect to know it all, right? You got to have practice in math. All right, so for number 3, the first term here, we're going to go term by term and explain a common little trick that comes with them. So we know that x to the 5th, this we can't just take the power rule of. You can't do it. It has to be in the numerator. So how can we do it? So we know that any power on the bottom, right, can be brought up to the top. So if this is 1 over x to the 5th, well, we know that the quotient rule tells us that we can bring up the power, but we have to subtract them. So this would be like, we could rewrite this term here as x to the negative 5th, right? Because when we bring it up, we have to subtract by the bottom term there. So quite simple. I'll subtract the exponent by that. So we could write this as 3 times x to the 5th, or to the negative 5th, I should say, to the negative 5th. Keep that in mind, right? You flip it, you have to change the exponent sign. Square roots are a little bit different. We can rewrite that as 3x, and instead of the big ugly square root sign that can get a little confusing when you're doing the math, I want to rewrite this to a power so we can just immediately give the power rule here. So saying to the 3rd root is the same as saying 1 over 3. Right, so if I take in my calculator, what's a perfect cube root? Would that be it? No. How do I not know one of these? Oh, come on, Corbin, you should know these. I'll find one eventually, hold on. 8, cube root of 8. So I'll show you on my calculator here. Cube root of 8 is 2, pretty simple. If I then put into my calculator this here, you get the same thing, right? So that's just kind of showing you that you can put it as a fractional exponent and it still means the same thing, right? Quite simple. So we're just rewriting the terms here. We're not finding the derivative yet. So any square roots you can put as fractional exponents. When you have a term in the bottom, you can write it as to the negative power. And then these are quite similar to what we've seen so far, so we'll just keep it as it is. So we're going to find d dx, right? And then, so let's just do this here. 3x to the negative 5th, the derivative of that, we bring it out front, negative 15x, we subtract 1. Negative 5 minus 1 is not negative 4. Don't try and go fast on these, it is negative 6. Right? And then looking at this, we have 3x times 1/3. That just simplifies to x. And then 1 minus 1 over 3 is negative 2/3. Alrighty. The derivative of 2x is, x squared is 2x. Pretty simple. And then we have a constant term, it falls out. So the derivative of this initial function is equal to this. This problem was just to show you the two unique elements that can be shown, which is when you have a term in the denominator or you have a square root. Hopefully that's helpful, guys. That's going to sum it up for the power rule. Next, we're going to be looking at what we call the product rule, which is when you multiply two terms together. Or when we look at the quotient rule. So catch me in the next one, guys. Have a wonderful day.